the first candidate to arrive. All right, all right. I'm muting you and then starting. Or should I? All right. If you have any questions, you can unmute yourself if there are no other attendees. All right. So we were. All right. So far, we have discussed something in R, and we have also discussed earlier a complete stack on big data, but we had left pig and hive and scoop. Okay, or did we complete pig? I don't think so. Have we completed pig, by the way? I'm starting the recording on my side as well. Okay, good. All right. So did we, if I'm not forgetting, I don't think we have finished pig yet. We just did a quick demo. All right. All right. So when we talk about big data analytics, although although the tools like R are great for small data, but they are not very great when it comes to huge data. Reason being, the R which we talked about just now is quite it can only tolerate it can only tolerate up to the data frame fits into the memory. In case the data frame doesn't fit into the memory, it gives a memory overflow. So as long as your data is small enough to fit into the RAM, R is great. But if you can't fit the data into the RAM, R is impossible. Using R is impossible. Also, as we discussed yesterday, the hierarchical clustering as well as the as well as the k-means clustering, both of them, hierarchical clustering as in taking a huge number of values and converting them into a hierarchy based on the distance. Similarly, grouping the elements into subgroups, okay, so in non-hierarchical way is called k-means. Now both of these have this complex nature of the problem. The hierarchical clustering is actually quite complex. First algorithm takes uh, takes around 2 to the power n, 2 to the power n. This is the of complexity of the hierarchical clustering. The other one was n to the power 3. So both of the algorithms are pretty complex. The sorting of the data, sorting of n numbers takes a time which is proportional to n into log n. When we talk about time consumed in computing, we do not talk about exact second. Instead, we talk about how is time dependent on the number of elements. Okay. For example, if you are given a list of n numbers, which is already sorted, searching linearly, as in we go to the first number and then check whether it is the number which we are looking for. If not, then we look for next one, next one, next one, next one, and we keep on going until we find the number. So the complexity of such an operation is directly proportional to the number of element we have in the list. And the moment we use a binary search algorithm, meaning we first jump into the beginning of the list, then we jump into the to the end of the list, then if our number is found we are happy, otherwise we jump in the middle, and we keep on jumping this way. It's called, in mathematics we call it bisection method. In computing we call it binary search. Okay, so that kind of methodology is proportional to logarithm of number of elements. Okay, meaning meaning if searching for one record takes 1 second, searching for sorry if searching for inside 10 records take 1 second, searching inside 100 records will take 2 seconds, and searching in 1000 records will take 3 seconds, and searching in 10,000 records will take 4 seconds. That is the proportional of because the time is proportional to logarithm of the number. All right. So and the other after this, so first one, the smallest and fastest out of these is doing a bisection method for searching, that is log n. The time consumed is proportional to logarithm of the numbers. Okay, in the list, if we are linearly going from top to bottom, searching for the number which we're looking for, or searching for a name which we are looking for, the complexity is proportional to number of elements, because in the worst case scenario, we have to iterate through the whole list. Okay. Second is the after this, the complexity of sorting n number of records. Sorting means you are given n records and you have to order those n records in some manner. The complexity of the doing the shuffling or ordering of these n records is n into log n. And what does it mean? It means that the 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 complexity has to sort n number of records, it will take so let's just assume that to sort 10 records to sort 10 records it has taken 10 seconds. Okay, to sort 100 records to sort 100 records it will take 200 seconds. So that's the proportional. Okay, and to sort 1000 records it will take 3000 seconds. So n into log n, so that's a complexity. And when we talk about these bigger algorithms such as k-means clustering or hierarchical clustering, the complexity is far more. In case of the hierarchical clustering, the first one where we go from bottom to up, it is n cube, and in the other case it's disastrous. There was an algorithm which we discussed yesterday. The complexity was more than n log n. Okay, so the moment our complexity grows beyond n, as in our computation is depending on number of elements, if it goes beyond n, it doesn't, so the computation becomes quite heavy. Okay, n cube is totally outright, and even more disastrous is 2 to the power n. So coming back to the point, so r in r, not only the memory is the issue, but also the handling of such kind of algorithm becomes impossible. It becomes totally impossible to get things done using r. Let's take the example of cars. Let's take the example of cars which we took yesterday. Okay, if we were just having 32 cars that has to be organized, those 32 cars had to be organized into an hierarchy. In case we had around 10,000 cars, I can bet that it won't be possible using our usual means of computing, because 10,000 means say 10,000 cars means 10,000 to the power 3, which is 10 to the power 12 into 4. So these much times, so you can imagine that how complex things grow as the data grows. All right, this is how the so most of these complex algorithms, even though they fit in, even though the data is fitting into the memory, the chances are that you won't be able to do the computation. Your CPU will be the bottleneck. So in case of R, either your RAM or CPU could be the bottleneck when we do the high-end computation. Now, if you have to do those kind of computation, you have to take support of MapReduce, either the MapReduce or Apache Spark. Okay, and how does those solve the problem? By the way of three, they come to you in in help in three ways. Okay, the crux of all these big data tools is that we use multiple computers to solve our problem. And when we use multiple computers to solve our problem, our CPU, we got multiple CPUs, we got multiple RAMs and multiple IO. Multiple IO, as in we can read from disk really fast. Okay, so and therefore we can make our overall process extremely fast. All right, now, so So we had discussed something called MapReduce. MapReduce way of breaking down your problem into into the maps and reduces. Now, writing MapReduce, it takes a lot of time. It is error prone. It's a non-trivial job. It requires a lot of work and it is not intuitive to churn the data using using these tools. Okay, using MapReduce. So it's not very user friendly way of solving the problems, and that is where Pig comes for the rescue. Pig or Hive. Pig provides you a beautiful language to do the data churning. Okay, so let's try to go through the Pig and let's try to see how what all functions does it provide and what all could we do to avoid to basically make use of Pig, okay, to churn humongous data. So Pig is an engine for executing data flows in parallel on Hadoop. Okay, data flows in parallel as in translate this data into something, summarize this data, aggregate this data. Those are data flows. Okay, so in Pig Latin provides you join order by filter, and it runs on Hadoop. It makes use of both HDFS as well as MapReduce. Okay, Pig directly reads from HDFS as well when required. So you can look at this code. This is probably the best way to learn any new programming language or any new query language. So Pig is more like a query language. Okay, the best way to learn any language is that you look at lots of examples and then you infer by yourself. Okay, and periodically go back to the grammar and look at what are the use cases. Okay, so first is let's have a look at the hello world. All right. So we have got load input from the file name big.txt, call the single field in the record. Okay. So input equals to load big.txt as line. Okay. So let me log in with my own account. Mehdi, are you able to hear me clearly? Are there breaks in the between? Okay. Okay. All right. So I'll go ahead. I'll not switch my internet connection. It's catching two Wi-Fi spots. One is no big data, other is L.no big data. Okay, so all right, let me open this. Yeah. Now let's go to Hue and try to execute this command. Okay. Now let's go back here, load this file. Okay, this file is not this way. Let me say data mr data mr word count. Sorry, word count and big.txt. Awesome. Okay, so there we are. And then we have, okay, so the lines which are starting with double dash are the commands, and here we are breaking down the line into words and then flattening it. You will understand it later. Flattening is like ungrouping things, and then we are grouping by words and then counting it. Okay, so let's try if our hue is working. And all right, here we go. So do you think it'll work? It says that input equals to load data from here as line, okay, and then words equal to this, group equals to this, count equals to this, and done. Okay, we can save it. How do you save it? You can save it hello world dot pig. Okay, now let's start. Oh, I was supposed to use my own account, not this one. Let me exit from here. Let me try to exit from here. It's not a good idea to use from this account. I must use my own account. All right. I was in the admin account, which I used to provision these servers. All right. If this doesn't work, we will use the command line. I'm more comfortable, honestly, with the console. Okay. And console is probably the better way because console has got better response time in case of hue. Because in case of hue, it's a long cycle. Okay. All right. Let's just start with pick. Input this, words equal to this, group equal to this, count equal to this, and dump count. Okay. And let's correct this data mr, and then word count, and then big.txt. All right. Let's see if this works. Okay. Let's save hello and let's start. Okay. Let's see what happens. I'm hoping that it'll work. If it doesn't, then we will use the console. Using hue for pig is generally slower than the usual one. Let's see what happens. What did it do? It says home yarn pig boot up does not found. That's okay. Is this the one? It says it succeeded. How come? Never mind. I'll just start this from here. So I'm going to use the command line. Okay, both the same thing. It's just that you have to log in on this black terminal and then type a command called pig. Okay, what does it say? It says that undefined alias called grpd. Now, here it says undefined alias called words, and when I say word equal to for each input, generate and tokenize line as word, that is correct. Mismatched input equal to, oh, okay. Actually, input is a keyword, so that is the reason it's not working. All right, that is the reason it's not working. Yeah, yeah. Let me say input, and for each input data, let me input data. Okay, let's just try it again and then see what happens. Okay, where is my terminal? Terminal is in the browser window, and ouch, I did a mistake. All right. Now I'm typing it again. I'm saying this time I'm using input. Now this is working. All right. So basically this input is a keyword in pig. That's why it was giving an error. I think that has been introduced in the new version of pig because the same example used to run earlier. Okay. You can see that it has done the word count for us. All right, so this is probably the simplest program. Word count. Hello World is kind of word count in big data. All right, now let's talk about Pig-Latin quickly. So Pig-Latin defines, allows describing how data flows should be read, processed, or stored to multiple output in parallel. You can create complex workflows. Multiple inputs could be joined while data is split into multiple streams, no ifs and fors. Okay, this is a quick example. In case of MapReduce, you have to do a lot of things by yourself, while Piglatin is small. So Piglatin is easier because you are using the predefined language, while MapReduce is little difficult and more time consuming. But Pig Latin has got limitations while MapReduce doesn't have. In case, in case there are some functions which are not there in Pig Latin, you will have to use a programming language such as Python or Java to create the Pig user-defined functions. Okay, so keep that in mind. So the way it happens in organization, an analyst does a lot of work in Pig and Pig Latin. In case he finds that there is something which is not possible using pig functions, it asks the developers to build a UDF for their work. Okay, so while developers build the pig UDF, analyst uses those pig UDF to use. So for example, pig UDF is nothing but a function. Okay, so the libraries are created by developers while the analyst uses them. Okay, so there are many use cases of pig. The first and foremost is ETL. ETL is extract, transform, load. So if you have to clean up massive amount of data quickly, pig Latin will be your easiest way to do it. Okay, so you could either use one Hadoop streaming. If you are good with scripting, if you are good with programming, then you could use Hadoop streaming and write your code in either Python shell or any other thing, or you could use pig for the transformation of the data. So whenever you have to format a humongous amount of data or trim some amount of data, you can use pig. Or let me take a better use case. Okay, you got these 500 terabytes of data from Apache logs in your organization. Now you are looking for certain pattern in the input. Let's say you're looking for those users who made the purchase from certain countries. Now, if you do the filtering of the huge data, the data input is huge, but the output might be very small. Output can later be churned using your usual single computer R. You could use R for churning the small data, and to produce that small data from big data, you would require either MapReduce or any other tools which are wrapper over the MapReduce, such as Piglatin, Hive, or Hadoop streaming. Okay, so you could use ETL for Pig. Now, so Pig is basically for iterative processing. All right. Looks like today none of them had joined, neither Anusha nor the other person, because that maybe the email did not reach them. Okay, good. Now, going ahead, so the other use cases is research on data, iterative processing, or batch processing. Please keep in mind that Pig and these systems are very much batch oriented because they use MapReduce, and MapReduce are generally written for the batch work. Batch work meaning the work that takes long time, and the data gets written into the disk after the work. Okay, after each step. It's not in memory. All right, the basic philosophy of Pig is Pig eats anything, meaning and whether data is structured or unstructured. Pig lives anywhere, meaning it's not only designed for Hadoop, but it is a general parallel processing language. Pig are domestic animal, meaning it is controllable. It provides custom function in Java and Python. You can create custom load and store methods, meaning if you have a new kind of database, you can use you can create your own load functions. Okay, so pigs are designed for performance, and they are really fast. All right, to start installing Pig, all you need to do is download it from there, extract it, and then rename it, and then start using it. So keep in mind that Pig is just a client. It doesn't have a server, meaning it doesn't have a state. So every time you define a data set, it will disappear and you will have to create it again. So Pig doesn't store or persist any data with itself. It can store the data in third party systems, okay, such as HDF and others. So Pig doesn't have its state. Unlike a database such as um, HBase, it doesn't have its own storage. All it does is whatever commands you give, it translate them into MapReduce and execute them in MapReduce, and that's it. Okay, so it's just a client. Now you can SSH to any of these, either F or E, and run the command called pig. And in HDFS, you have the permission to manipulate your home folder. Okay, so sometimes you want to test it locally before bothering the server. In those cases, if you have installed pig locally, you can say pig minus x local, and then you can use the same command, but there'll be that will be running the pig that will be running the MapReduce, which is a pseudo MapReduce, not the real cluster, but the pseudo one. Just like you have the MapReduce for testing. Okay, so there are many command line arguments which are supported with Pig. So the first is that you can pass the script name on the command line argument, As well as if you just want to execute one single command of pig, you can use pig minus els, and then you can see the version, and then you can see the options. The prompt of pig, the one which we started here, this is the prompt called grunt. Okay, from here from here we can do a lot of things here. This is probably the easiest and quickest way to access hdfs. Okay, so we can also see, we can do a quick hdfs manipulation from here. Here what I did was I changed to a folder. I listed down what is there in the folder, so all these commands are interacting with the HDFS. So you can see I just created a folder using mkdir here in this temp directory. Okay, so that's the power of pig. Using pig, you can manipulate the HDFS. You can talk to HDFS instead of typing hadoop fs minus ls every time, or you can execute a job or kill a job from the pig console. All right, so every processing step is a new condition, new set. Okay, so when we did just now, what we did here was, if you see here, every step here has got a data set. So first one loaded this file into this data set. Second command translated input data into words, and then third one converted words into grouped, and then grouped got converted into count, and then dump. So except for dump and store, every statement is is a step that results in a new data set. Okay, so case mostly it's case sensitive. It's just the external functions or the functions are case sensitive. You have multi-line comments as well as single line comments. All right. So how would you find the average value of this kind of data? Imagine you have got few say around 20 gigabyte of data in this form called NYSE dividends. Now, how would you find out the average value of anything? Say, for the first column is the New York Stock Exchange, the name of the stock exchange. The second column is the stock ticker, we call it stock ticker, or and third one is the date, and fourth one is the value. In general, in case of SQL, all we can do is we can say select ticker comma average of the stock value, group by from my table called NYSE underscore dividends, group by the ticker, right? So you could use a simple group by in case of SQL. If you are from SQL background, you can infer that. Okay, here in case of pig, this is how the data looks like, the query looks like. We say that load this data, then we are saying dump just to check what is in this data, right? And then we are saying explain, we are saying grouped equals to group, and then average, then store it, and then concatenate. You should try this commands by yourself. Okay, you should try these commands by yourself. Okay, I've sent to all of you. All right, now going back to, so I'm going a little back and forth. I'm showing you the script, going back to the describing the language and so on. So these are the basic data types. Int, long. Int is for storing integer. Long is for storing very big integer. Float is for storing the decimal number. To store a huge decimal number, you could use double. If you want to store the string, you store as char array. If you want to just don't know what to do with the string, the by default data type is byte array, and you have datetime. All right. So there are these complex data types as well, such as map, tuple, and bag. So map means it's a collection of key value pairs. Tuple is like a row in the database. Bag is like a big a collection of rows which is equivalent of a database table or data set. All right. So bag tuple and map, these are the complex data types. All right. Now, pig is not very particular about schemas, meaning you can either load the data. Okay, you can either load the data and specify that, hey, my data contains this as integer, this column is of type integer, this column is type float, or you can completely skip it. Okay, unlike the okay okay so unlike you okay so sql unlike sql here, uh, every column has got a data type. Sorry, I'm extremely sorry, I'm getting distracted. So in sql, whenever you are defining a table, you always specify the exact data type of each column. Here, that is not the case. Even if you're not specifying the name of the column, it is okay. You can always refer it by its index. Okay. Same is true if the data types are of complex nature, like map, tuple. You can skip it, or you can mention that, okay, I'm expecting a data type called map here, or you can first declare the name of the variable. That too is optional. Further, you can go one step further and say, hey, I'm expecting a map in this field. While loading, take care of that part. Then you could go one step further and tell that what kind of data will this map contain. Will this map, the key and the value, what will be the value data type that we can go ahead. So here we are saying map contains the value which is a tuple. So it's really complex data type. Okay, so you could go with that, and you can later on translate data from one type to another by prefixing the other data type in front of it. Okay, so here is the simplest way of loading data. You could say divs equals load data slash dividends, and then it will load the data from that location into divs. Now notice that by default it uses tab as a separator. So this data by default is separated by tab. Okay, let's have a look at this data. Okay, let's go to this column and we say, I think there is a command called head, or it's not there. Okay, never mind. So let me just close all of these. Okay, all right. So here we have this. We can load data like this. And then by default, this data will be tab separated. And how do you look into this data? You could go to Hue, or here go to File Browser. All right. You could go to File Browser. Okay, so here we are. All right. So this is the tab separated data, and by default, the Pig expects the data to be tab separated. In case your data is comma separated, you can do using Pig storage and put a comma there, and then you can load. In case there are many files with the same prefix, you can load all of them into a single data set and all of them will be concatenated together. In case you want to load the data from HBase or some other database, you can use a different storage like this. So using Pig, you can load the data from various sources. Okay. Like here, you can see you can load the data from many places. Similarly, you can load the data using from a JSON format into this particular table, and this file has to be in the HDFS. Okay, so you can check what is the type of the data set using explain or describe, and in case you want to use a syntax highlighting tool, you could use any of these. Then opposite of load is your store. You can store the data into the disk, or you can say dump, and it will dump the data which is inside that particular data set. Okay, it will show it on the screen. All right, now comes another operator called for each. If you want to apply something or you want to pick up some columns or translate some columns of it, you can use for each. Using for each, you could basically uh, iterate through all the records. So what does it do? The syntax is for each and then the dataset name, generate, then the column names. Here, you could also apply the mathematical formulas like val into val. Okay, so all it's doing is it's taking record by record and translating it into something that Hadoop MapReduce does it by default. Okay, you can store these values afterwards into this. So we talked about load. Using load, you can load the data from HDFS and other sources. By default, it loads using tab. If you have to use load a comma separated values, a CSV value, you can say load the file as this using pig storage and put the comma, and then you could iterate through the records using for each and store the data using store into HDFS. And while storing as well, you can say using pig storage and put comma, and then the data will be stored as comma separated. All right, now for each is an interesting operator. Using for each, you can iterate through the records. For example, let's say prices is equal to load this, and we are specifying the name of the columns like this. Okay, so prices will have these many columns. Now you can iterate over the prices, generate close minus open and kind of operators, and then you can also generate $6 minus $3 kind of things. Okay, so you can subtract and do mathematical operations on the records. All right, Mehdi, are you with me? No. Great, great. All right, so you can also select the ranges like this. Instead of saying star, select star, here we say dot open dot close. Dot open means up all columns up to open, and open dot close means all columns from open till close, and volume dot means all columns after volume. Okay. All right, so I'll skip these questions. These are not designed for you. Okay, let's take a break of 5 minutes and we'll be back by 9:06 p.m. IST. All right. All right. So should we start now? It's already 9:07. Great. Great. All right. So the for each, the one which we talked about, using for each, you can iterate over a data set. The data set could be complex or could be, basically each individual element could be simple or complex. For example, here we are iterating over a complex data set like baseball. Okay, let's have a look at this file. This file is a complex file. Where is my big data set? These are the common data sets. You cannot change these data sets. These are read-only data sets. Okay, so you can see here. All right, so you can see here the data set is complex. Here it's a simple string, another simple string. This is the history of the various baseball players. This is the name of the baseball player. This is the name of the team, and then the characteristic of the player, and then you have the records of the baseball player. It says that this particular player has played these many games and hit by pitch by in these many times, and so on. Okay, so you have this great complex data. If you want to load it, you can simply load it just like that, because the data is well formatted, meaning this is in inside curly brackets. Okay, because it's basically, what do you say, it's a bag of single column values. Each row is only having one value, so it's a bag of this kind of tuples with single column. And this is a big map. This map contains key and value. Okay, so you can simply load it because map is having squares, square brackets around it, comma separate value, while bag is having curly brackets. So it's adhering to the standard of big. So you can simply say a equals to load this data. Sorry, b ball equals to load this file, and it'll load it. And afterwards, you can iterate over it. Okay, so you can see for each generate name and batting average. We are trying to pick up the batting average of each player. All right, you can try this out, and it's pretty straightforward actually. So you can say, I'll show you quickly. You can say this and say dump average. All right, here you go. Okay, so we have found the average of the batting average from this complex data. So this is the reason why you could use pig for iterating over a lot of complex data. So you can iterate over complex data using for each. Okay. Also, you can do the complex operation like multiplication using for each. The detailed functions which you can apply on each of the during for each are listed here. You could say you could say even the mathematical operations you could apply on each value, and you could also apply regular expression. So this is very important for you. Have you been able to go through the regular expression course, Mehdi? So this one, is it visible to you? It's just a one session of around 20 minutes. All right, great. So basically, using pig as well, you can break. one complex data into the format and pick up the column which you want to pick up. Okay. So for example, here we are saying regex extract, and from here we are saying this is our input. So here will be putting the value of that column, and then we would say this means we are splitting the data by column and then picking the first value, meaning only the IP address. If we put dot here in between them, then we have, and we say 1, we will get 192. All right. Or sometimes you may want to extract all, as in convert this into two fields. It will return us two fields like this. Okay. So why? Because we are saying this colon this is our regex format, and we are putting brackets around it, meaning captures around it, and then it will return us a tuple of two columns, as if we have split it into many formats. So if you are given, say, complex log files, and you want to uh, load the data in that fashion, you could use regex to load the data. This is probably the function which you will use more often. Okay, you can split your input data in many creative ways. You could say my first field is 3 character long, and then second field is 20 character long, and fourth field is afterward everything. And that regex extract all will do the magic for you. Okay, so that is the magic of that's the magic of pig. All right, there's the magic of regex. All right, so you could go through these built-in function list. It's a huge function list which are provided as a built-in library for you. And in case this library is not sufficient, there are third-party libraries available. I will explain to you how to use them. Okay, so you could do group by in pig. Group by is nothing but grouping the whole element based on a certain field, and then it does not do aggregation. Unlike SQL, where everything happens in a single query, here it doesn't happen in that way. It only groups the element. You can see that this which has been grouped by age. Okay, it basically contains three columns: name, age, and GPA. So when you group it by age, what happens is that it creates a bag of values like this. Okay, it created a bag of values like this. Okay, which are basically, a bag is nothing but a collection, and therefore all the values for each of the age have been grouped together into a collection. And then in the next step, you could do things like for each a, iterate over this, break down this, and all that. Okay, so that is group. And then there is a flatten. Flatten is opposite of this. Let's say you are given this list called Sandeep knows C, C++, while Arun knows Shell and C, and C Money uses Java, knows Java, C++, and Lisp. Now what do we want to do is we want to group it by the programming language. Okay, we want to find out who all know C++, who all know C, and who all know Java. So what you do in this case is, first you flatten. Flatten means it will do the ungrouping. So it will convert this data into Sandeep C, Sandeep C++, and Arun Shell, Arun C, C many Java, C, and so on. And then now you can do the grouping of this based on the second column. All right, so that's flatten. Next is filter. You can filter certain record based on conditions. Okay, and that condition could be a particular regex, or it could be a mathematical operation. Okay, or it could be a combination of many operations, and those operations could be combined using logical operators such as and or not. Okay, so basically you can do all kinds of complex operation using pig's filter. Filter basically will remove those elements, will keep only those elements which satisfy the condition. Okay, Now it has got order by and distinct. Order by basically orders the data by a particular column. Distinct find out only the distinct values. Okay. And it has got joins. Joins, there could be join on a single key. So please make a note of join. When I say note, as in mental note, so because these slides are anyway available to you. So join is join between one and another based on a column from this data set and column from this data set. Unlike the joins, unlike the joins in the traditional sense, here joins are e- strictly equijoins, as in we compare the value from one data set, we equate, not only compare, we cannot compare here. We say that this field from this data set is equal to that field from that data set, and that's where the single key comes into play. That's where the join comes into play. Now sometimes you want to compare, you want to find out, or you want to group the records from two data sets together based on more than one field. In that case, you use the composite key, as in we want to say exchange comma symbol from daily. Bring all those records together whose exchange as well as symbol are equal to exchange and symbol from the other data set. And this will do the job. Next is self join. Self join is not so straightforward in Pig. You will have to load the data twice and do the self join. All right. All right. Now, the main difference from join of Pig as compared to the RDBMS is that it does not, this is wrong in case of Pig. It does not let you compare the two values in the join. Why? Because in MapReduce, it uses MapReduce, and in MapReduce, the only way to bring two records from two different data sets together is by making the key, by making the key by making the field on which we want to join, we make that those columns as the key, and therefore since the key, all the values for the key are brought together, and all the data sets belonging to those values are brought together. All right. Now, in case of joins, the normal join, equijoin, as in a.id equals to b.id, is quite straightforward. You can see A has got two records, two rows, one Sandeep, two Ryan, and B has got one Giri and three Saha. And when you join the two data sets, you get one Sandeep, one Giri. Okay, you agree with this? It is comfortable for you? When we are joining these two data sets like this, it will bring those records which are equal, uh, where the ID is matching. Okay, where the ID is matching. Now, what if you want all the records from one side, all the records from one side, okay, all the records from one side, and okay, so what we want to do here is we want to bring all the records from one side into the output, whether there is a value on the right hand side or not. Okay, say for example I want one Sandeep and two Ryan in the output, even if there is no record on the right hand side. Why would I use it? This can be used in many creative ways. Let's say I'm trying to find out all those records for which there is no value on the right hand side. Okay, so I'm trying to say A minus B. I want to find out all the records from A side which is not there in B. So all I will do is first I'll join and then remove that, then we'll keep only those where the right hand side values are empty. Okay, so this is called left join. All we have to do is place left in between, and that's it. So it will bring all the data from the left hand side, which is A, into the output. Okay, and then we can say join A by ID, which is right, and then join with the B, and we get the results. Okay, so this is what it is. All right. So you can see here, it basically brings all the record from right hand side in the output. All right. Now, sometimes you want to, so this one, what will be the output, Mehndi, of this one? Yes. We are saying join A by ID, right outer B by ID. So here we said left join, or we could have said left outer join. Both are same thing. Okay. Now, question is, what happens in this case? All right. All right. So what we do here is we says right outer, so it brings the data from right hand side. All right. Sometimes you want to bring data from both the sides. Something like union. We say A union B, meaning records from A and records from B, except that the record should not be replicated. So we can do that easily by saying full join. Okay? By saying full join. Alright, we could say join A by ID, B by ID equals to N1 records, join A by ID left, B by ID equals to N2 records, and so on. Okay, yeah. Any questions at this point? So, if we are doing full join, how many records will there be? Let's say there are two data sets A and B, and when we join them on equi-join, as in the inner join, we call that non-outer join, where only the records which are there in both appear in the output, which are N1. If we join A and B and it's a left join, meaning all the records from A will be there in the output, whether it is there in the right hand side or not. And then we say A by right, we join A and B on right. Okay, so it is N3 records. So when we say join A by ID full means records from both the sides. All right, so what will be, how many records will be there? Okay, so you can see in case of full join, what we have is one Sandeep, one Giri, two Ryan empty, and then empty and three Saham. Okay, so how many records will be there? All right, so the total number of records will be N1. So the data from both the sides, when we say full means data which is common in A and B plus data which is only in A and data which is only in B. Okay, which means data from both the sides, which is N1, and data from left hand side, which is N2 minus N1, only in the left hand side, which is total number of records in the left hand side is N2. All right, and then we can sum it up, and then these are the total number of records. All right, never mind. So yeah, this is okay. Let's move on. All right, you can limit number of records if you are churning big data and you just want to see first few records. In those cases, you could use limit divs 10 and then dump this. Okay, this is good way of working with big data so that you can just churn few records and do not bother with rest. And instead, and sample is a good way to generate a sample. Let's say there is a huge data and you want to practice, you want to figure out certain pattern in a small sample of it using your R. So you can simply say sample, and then it will give you a small sample out of the huge data, and then take the sample and use it in R. All right. So sample is a very important function. It'll give you a random sample of the data. Okay. Now, sometimes you want to exploit the parallelism by yourself. This is something very specific to pig and it was not there in traditional data churning systems. Okay, because the speed is a very prime concern. All right. So, so in case of reduce, in map reduce, there were a reduce phase. Reduce phase gets executed that can also be executed on multiple nodes. What does it mean by reduce? Reduce means in case of map, all the values for each key has been grouped together. What do we want to do with these keys? How do we want to aggregate these? And that function is called reduce function. And that reduce function should also be executed on multiple machines so that if there are many keys, if there are billions of keys, so one single machine should not get overloaded. These billions of keys can be divided on multiple machines and then the aggregation can be run on multiple machines. All right? All right. So that's about. So sometimes you want to control number of parallel processes in pig that can be done using pig. And if you don't specify parallel keyword by yourself, it's completely okay with that, and we'll try to create number of reduces based on how much gigabytes of data is there. If there are 20 gigabytes of data, it will create 20 reducers. Okay, per GB it creates one reducer. But in case your data goes beyond 999, it won't create reducers beyond 999. Okay, all right. All right. Sometimes you want to use external functions from Java. You can use built-in functions and define functions from Java like this. Okay? If there is some function which a developer has written for you, you can utilize that. You can use that function and import that function and start using it as if it is an internal function. So we say define invoke for string whatever function is there, and then we use it. Okay, so this way we can quickly import the import function from a library and start using it. Okay, if the function written by developers is in Python, you could use the following way to run a Python function. All right. Sometimes you may want to create your own UDF. In that case, this is the procedure, and I will skip it because you may not like to use this way because this is mostly for Java developers. So you can basically write here's the example code. You can download it if you are interested and try to compile it and then generate the jar and register it and run it as if it's a internal function of pig. Okay, sometimes there is a function available to you by public. There are public repositories of pig function. Okay, it's called piggy bank. Piggy bank is quite a huge collection of functions contributed by many kind of people, many different kind of background kind of people. Some are from statistical, some are from various different kind of people. But this piggy bank is definitely very smaller than what we have in R. Okay, so library of functions from other people, same as UDF, just that the code is available. Just that the code is available. Okay, you will have to compile it, you will have to check out that the code and then compile it using these commands. Like you can use ant command and then it will compile the code, and after compiling the code you can put this piggy bank jar somewhere. Say for example here in data/pig, I've already copied it here. You can use it. Okay, you can use it. All right, and register it using something of this sort. You can simply say register data like this. Okay, and you may have to copy it to the local machine before you run it. All right, so this is the collection of function. There are many collection of function. You can go here and understand what kind of collections of functions are provided by Pig for you. Okay, you could go here and you will see there are many functions available here. There is something called pig tool. It's a very good useful library. Okay, it has something called data foo. Data foo provides you things like standard deviation. Okay, standard deviation and statistical function. And then you have elephant bird. Elephant bird is a collection of functions which provides you load various kinds of functions to load the data from. Okay, and this Pygmalion is basically to load the data from Cassandra. And then you have Amazon. It helps you uh, interact with Amazon. And then there are so many other wrappers, like if you want to execute Python and so on. Okay. So there are so many third-party tools which are provided to you. Okay. And all right, good. So using piggy bank, you could utilize a lot of things under piggy bank. You could basically check out and start using those as such. All right. So there are many projects, not only code committed to piggy bank, which can be used inside Pig. You can just, in general, download anybody's jar and then register it and start using it. Okay. Jar is nothing but zipped version of Java code. All right. Now, sometimes you want to do for each inside for each, that you can do if you put a curly brackets inside it. Okay. So, for example, in this case where you want to count distinct name in a city. Okay, so you have to first group by, and then in the list of people who are after grouping by, we can do the distinct in the list of people, and then apply the count. Okay, so this is called for each nested. All right. Now there is something interesting about pig. It's called fragmented join. This is something I would like to pay a little bit more attention, because this is something very different from our traditional SQL. Okay, this is something I would like to pay more attention because this is very different from our traditional SQL. Now let's say you have two database tables. One containing name and country. Now, another database table is country and code. Now, the second database table is very small, very small, while the first database table is having billions of record. and second database table is only having say 200 records. Okay, now if we do the usual join, it is going to bring it together and will run the map reduce, meaning it will try to do kind of pick up one record from one side, pick up both the data set, sort them, and then merge it, and then group it, and then do the magic. Now, grouping and sorting is a huge exercise. It's a huge exercise for MapReduce. If you have a huge data, grouping might take a huge time, even if it's running on MapReduce. So to solve these kind of problems in case when one data is big, other data is small, if you're joining two tables, one is very huge, another is very small, this information is only available to you. Pig would not try to detect it. Therefore, you can optimize the operation by saying that it's a fragmented join. You can say that it's a fragmented join, we call it a replicated join. The data set which is smaller, we mark it as replicated. We say that join persons by country, CC by country, and using replicated. Okay, so therefore these two data set get joined, and then we can it will be joined in such a way that there is no reduce phase. There is no sorting, there is no grouping. All it will do is it'll take the second data set, load it into the memory, and do the join in the map phase itself. And that is the magic of the keyword called replicated. All right. Now, sometimes you have the joins where for a key, in one data set, there are huge number of values, and for some keys there are very few values. In those cases, joining will be really really difficult, and you need to be extra cautious because it might overflow the MapReduce's memory, right? So because pig is going to convert this SQL, this piglet into MapReduce, and therefore it might overflow the memory. Now, in these cases, the data which is suspected to be having skewed, this is called skewed data, as in for some keys there are so many values, and for some keys there are very few values, and so many and very few, the definition is the ratio is around 10,000 times. And that's when the skewed keyword comes into play. So skewed keyword tells pig that, hey, you are joining good, but keep in mind that this data is skewed around this key. Okay, this data is skewed around this key. All right, now sometimes you want to join sorted data. Okay, you know for sure that last time when you stored the data, the data was sorted. Last time when you joined the data was sorted already. When you were saving the data, it was from MapReduce phase, and therefore it was already sorted, and there is no need of sorting because sorting means ordering the data. So when you take two data set and try to join the two data sets, okay, when you try to join the two data set based on a particular column, right, it does sorting internally, meaning it will make a map reduce phase, and inside map, after map reduce phase, it will shuffle all the keys, try to sort it so that the keys from both the sides come together and does the join. But if you know for sure that your data is already sorted, you can inform Pig, and Pig internally informs MapReduce saying, hey, both the files are already sorted, so you don't need to sort them individually, and you save a lot of time. And that's where the merge keyword comes into play. All right? And sometimes you want to co-group. Co-group means you want to group the two tables based on a column and then join. Okay, although you can happily say group and join, but you might end up with two map reduce phases, meaning two times sorting. The Hadoop will try to sort the data two times, even though joining and grouping require sorting around the same column. Therefore, it makes sense to group and then join together in a single shot using co-group. You can alternatively use first group by the same column and then say join this data with other data and say merge. Instead of letting pig try to sort it again, you say to pig that hey, it's merge only. All right. All right. And Mehdi, keep in mind that no matter what you do here, like here we said users equal to load users, cinfo equals to this, join equal to this. None of these will get executed unless you say dump or store. Unless you either call dump function or store function, none of this will happen. Just like Spark. If you remember our discussion in Spark, nothing gets executed unless you call an action. Similarly, in Pig, nothing gets executed unless you say dump or store. All right? All right. So this is co-group. And sometimes you want to append one data set after another data set. This is called union. Union is little misleading, but this keyword has been picked up from the relational databases. You take the first data set, append the second data set afterwards. All right, that is called union. Now sometimes while you're appending second data set after the first data set, you want to match the columns. You want to put the right columns, right values in the right columns. And that's where we say union on schema. On schema as in assuming both A and B have the name of the columns. Both know that these are the name of the columns in A and B. So while appending the data from B into A, it will take care. I'll try to bring the same names of the column into same. Okay, so basically, if you have n1 records in A and n2 records in B, the total number of records in A union B is always n1 plus n2. Total number of records in A union A and B is equal to the total number of records in A plus total number of records in B, no matter whether it's union or union on schema. Okay, the only thing union on schema does is it tries to put the values under the column name with the same name in both sides. All right. So for example, here when you say A union B, it takes all the record from A and it takes all the records from B and put it in the output. But when you say union on schema, then it notices that these two data sets have three columns, X, Y, and Z. So it creates the columns from the union list of two, distinct list of two, to both the data sets, and then you you put the data accordingly. So it created X, Y, and Z. So when you say union A and B, okay, so it is actually union B and A. So it's B12 A11, B12 A11, correct, because it doesn't have a Y. And then B22 and B21, B22, B21, the Y is empty. Then it picks up when you are concatenating, okay, or unioning. Then this is what happens. Now this time while putting the A after this, it doesn't have Z column, and therefore this is left empty, and you have A11, A12, A21, A22. All right, that is union. All right. Now sometimes you do want to do a cross multiplication. Let's say there is a data set which contains good, bad. Okay. Then there is another table which contains boy, girl. Now what you want to generate is good boy, good girl, bad girl. Okay, so you want to do a cross multiplication. For all records in A, you want to generate a combination with all records of B. For each record of A, you pick up and combine it with all the records of B, and then pick up the next record and combine it with all the records of B, and then keep on doing it again and again, and for all the elements of A. And that's what is known as the cross multiplication, or cross. And the way you do it is output equals to cross A comma B. All right. This way you can generate the cross multiplication. And where is it required? Where it is required at many places. It is required at many places, such as the matrix multiplication. Okay, such as matrix multiplication, or there are many more tuple finding mechanisms. Okay, where it might be very useful. Sometimes you want to put a parallel with it, because computing the cross products is a costly affair. Computing the cross product is a costly affair, and therefore you might want to run it in 10 parallel reduces, or 50 parallel reduces, or 100 parallel reduces. Okay, all right. So this is called cross product. Now, sometimes, since as we will notice that pig basically is will be used in either ETL or in reporting, which means it has to have the behavior of a reporting engine, and is every report must accept parameter. If you have used any reporting engine like BERT, or Crystal Report, or any other report, it needs to accept the argument. For example, you generated a report on daily behavior of the users. So you have to pass in the current date so that the query runs against only today's date, and thereby you have the output. So you can always pass the argument like this. You could say yesterday equals to filter daily by this date equals to daily by date equals to dollar date. This is the variable which you can pass from outside. You can pass from outside like pig minus p. This is the parameter you are passing, and this is the name of the script which contains this whole list of commands. Okay, so what is a pig script? Pig script is nothing but collection of pig commands, one line in a column separated by semicolon, and I mean ending with semicolon. Every statement ends with a semicolon. So you take all these statements, put in a file, and execute it with pig, and then you get the output. All right. So the pig parameter file is you have a parameter file here. Okay. In case you got lots of parameter which you don't want to type in the command line, you can put it in a separate file, and then you can pass that as argument. Okay. All right. So you can split input data into many data sets, or you could even use some other technique without even using split. Okay, so you can split one single data set into multiple sections. So for example, here we are saying load web logs. Okay, and then we are saying split web logs into April 3, April 2, April 1. And then we're doing independent computation on each of this. So you can see that split is not really like split, because when you split something, one thing doesn't go into the two forks. If you are splitting one file into two portions, some things do not get replicated. Here, that's not the case. Here, when you say split W logs into these three, the data might get go into two forks. Okay, for example, the records of April 1 would go to April 1 as well as April 3. Okay, you can see here data pertaining to the timestamp of 1st of April will go to APR03 as well as APR01. Also, some of the data might get dropped. So that is a little misnomer, but that's all right. A record can also be dropped out, or record could go to the multiple legs. All right. Now, pig has got non-linear execution. What does it mean? When we are executing something, okay? So when we say dataset A equals to load dataset, load this file, then filter this, filter that, generate another dataset, another dataset. So it's nothing but we are defining an order of things. Okay, like the way we define that when you go to office you wear shirt and you wear trousers, and after that you wear shoes, and then this. So instead of saying in the complete holistic manner, we say that you wear shoes after you have worn the socks, and you wear the socks after you have worn the trousers, and so on, and you wear the trousers after you have taken bath. So that's what we are saying. Okay, when we say a equals to for each b, it means a is done after b has been computed already. All right, so whenever we say dump x, all the things on which x is depending will get computed and executed. Okay, and that's why we call it non-linear execution, because in our usual programs it starts on the top and goes down till the end, right? Here that's not the case. Here it's bottom up in the sense that bottom up means that we start with the one which we so we start at the point where we say dump, and then it moves up, finding out who all this data set depends upon, and that's what is called bottom up. All right. Now, there are a few differences between pig latin versus sql. So pig latin, you must have noticed by now this difference is quite not quite big, but there is a difference. One, in Pig Latin, the life was very simple. You did one thing in a statement. You did not try to do everything in a single shot. And that's what is the beauty of Pig Latin. You describe how to process the input data. In case of SQL, you describe a single question that, hey, I want this. And all of it has to be done in a single statement. Okay, Pig Latin is designed for distributed computing, while SQL was bottom up designed for RDBMS. So from the day zero, the SQL has been designed for this. So here basically we are comparing Hive and Pig, because Hive does exactly what Pig does, except that it takes the SQL and converts it into MapReduce. Okay, Piglatin targets multiple data operation and parallel processing. For SQL, we have multiple data operations. The query gets complex. For SQL, if you have many data operations, the query will become really messy. I remember one of my SQL statement going beyond 2 pages, and nobody had a clue what to do. So we had to break it down into temporary tables, or we had to convert it into set-based operations. So which is set-based operation is nothing but similar to Pig Latin. Okay, creating views and then using them later on, and so on. So creating views is very similar to creating dataset in Pig Latin, because when you create view in SQL, it doesn't do anything right away. It just makes a note that, okay, this view means this particular SQL query, and whenever that view is used, that SQL query is executed. Okay, so Pig Latin, each dataset or each what do you call, we also call the dataset as relation. Okay, is basically kind of a view. It doesn't have any data in it. It just it's a representation saying a equals to load this data. So Pig says, okay, I have noted it down. When you need to dump the data a, then I will do all of this. Then I'll talk to HDFS and get it done. So Pig Latin can be used when the schema is not known or incomplete, or it requires it doesn't require well formatted data. Okay, it can handle all kind of data inconsistencies easily, while in SQL the data has to be pre-prepared, because when you create a table in SQL you have to define all the columns clearly. All right, you have to define all the columns clearly. All right, so that was pretty much about pigletting. I would like to take you over an example of pigletting which we can utilize now. All right, so let's say we want to do the computation of movie recommendations. Okay, for that we need to clean up the data. All right, let's have a look at our data. How does our data look like? All right, you see there is something called ML100K. It has got some data in u.data. All right, here is the data which is tab separated. Okay, no, not a good idea. I'll just take a better case. Okay, let's take this one, not this one. We take, go back. All right, let me describe what is this data. This data is the ratings of the movies. Information about movies is in movie.dat. Information about users is in user.dat. So there are so many users who have rated for various movies. This is the ratings. So user number one, the definition of one is in that movie user.dat, has rated 1193 as something. Okay, so this is the rating he has given. And at this time, so let's say we do not want this. Instead of this, what we want is we want to separate these by comma. Okay, we want to convert it in comma separated, and we don't want the last one. We want only the first three columns. Now how will you do it using pigletting? Let's see. Okay, so we got this data using this data. Let me make a note of it here. We say ratings raw equals to load this, and we say using pig storage, and we can say this. Okay, here we are saying our data is colon separated. All right, our data is colon separated. All right, we have ratings.raw. Now next thing we want to do is after loading the data in column separated format, we want to figure out. So also note that it is double column separated, not a single column separated, which means that there will be empty columns, right? So we will say only first three equals to for each ratings raw and generate $0, $2, and $4. Okay, because $0 means starting column, and then there will be an empty column because it's separated by double column, and we are splitting it by column. So therefore there will be an empty column, and that's how we reach to only first three. And then we could say store only first three into my output, my movie output, using pig storage, and we are saying save it as comma separated. All right, does it sound good to you? Let's try if it happens. Okay, it says that unexpected symbol near, yeah, we have to put semicolon. All right, we have to put semicolon everywhere. All right. So it has started the work. At the end of it, there'll be a folder called My Movie Out containing all the files uh, having our data. If there are multiple reduce phase, okay, if there are multiple reduce phase, there will be multiple files in this. Right now, I don't think that it has got. So let's see. Okay, my movie out. So I say this. All right, this is my home folder. When you say cd enter, you are in your home folder. And here you could go to the one which has been created just now. See, ratings.csv. All right. How did it automatically complete? I don't know. So here there is this file. You can see there is this file. So the output has directly gone from mapper. There is no reduce phase. That's why there is M here in the output. And then we could say things like this. You see, it has saved our data as comma separated from colon separated and removed the last line. All right, sounds good to you? You can try doing the same thing in your account and it should be good. All right, so that's pretty much for today. And please be a little early. And tomorrow is Friday, so I may not be available. So the next class, let's keep it on Monday. Okay, let's keep the next class on Monday. And can we keep the next class of 3 hours? Maybe? No? I want to go over Spark R on Monday. All right. So the things which are left right now is a little bit about Hue and introduction about Scoop and Flume. Just I would just go over what do they do, and then we will go into MLlib and Spark. I want to spend a little more time on Spark, giving a demo, and then and then giving a couple of demos of MLlib so that you can start using MLlib. Even though you don't understand the nitty-gritties of each algorithm, you should be able to use those algorithms. All right. So we'll try to do that. All right. Thank you, Mehdi. Have a great weekend. Bye bye. We'll see you on Monday.